Right, we are back with some quick math. We are still busy with Euclidean geometry. I think we've covered up until theorem 5, so this is theorem 6, which is basically just a build on top of theorem 5. Theorem 5 was opposite angles of your cyclic quad. So let's just look at how theorem 5 works quickly, and then I'll explain theorem 6 on top of that. Yeah, like, subscribe, share the video with anyone that does math, technical math, grade 11, grade 12. They will definitely benefit from it and help the channel grow. Great. So this is B and D, right? So let's make D a random number. Let's make it 70. Okay, so then B, so this is how we would write this out, right? So we'll say angle B. If you want to solve angle B, let's call it X. Angle B plus angle D. Now there's multiple angle D's, right? There's this one and this one, so we need to specify. So we would then say A DC. So you add those two together, you get 180. We know they are supplementary, right? So our reason, let's erase that. Our reason is opposite angles of our cyclic chord. Right. That is a Q. Opposite angles of a cyclic quad. Great. Let's fill in some more things over here. So then B, let's call that one X. And then let's see, 70 degrees plus the, well, not plus, is equal to, let's fix that, equals 180 degrees. Right, then we want to get rid of this, so we subtract 70 on both sides. So X would then equal to 110. Great. So we solving for X, and that's what it would be based on theorem 5, right? Okay, let's go back at our picture quickly. Let's add another value. Let's call this one Y. Let's put Y on the side. Okay, let's solve for Y. So what we can see is ADE is a straight line. So then the 70 and the Y are also supplementary, right? So what we would say is ADC, right, plus Y is equal to 180 degrees. The reason for that, angles on a straight line. Angles on that's a straight line. Right, great. And then if you have to solve this, so we know that that was 70. So 70 plus Y equals 280 degrees. Get rid of the 70, so we're subtracting 70 on both sides, so Y is going to equal to 110 degrees, right? So let's go look back at this quickly. So let's clear some of these things. So we said this Y, we figured out that that was 110 degrees. We also figured out that this X was 110 degrees. So the thing that we are supposed to notice is that these are the same thing. Great. Right, so what is our new theorem? Our new theorem tells us that this angle over here, angle B, is equal to the exterior angle of your cyclic quad. All right, so angle B, let's erase some of all of these things. Okay, theorem 6 tells us angle B is equal to angle, let's call it CDE. Why are they equal? Exterior angles of your cyclic quad. Great. Okay, so then if we look back at our cyclic quad over here, you know two things for all cyclic quads. The one is interior angles are supplementary, right? That means this one plus this one, if you add them, you get 180. So that's the first thing you know about cyclic quads. The second thing you know about cyclic quads is the opposite interior angle and the exterior angle are equal to each other. Great. All right, so now I just wanted to make some more comments quickly about these two theorems, right? Something that is going to be exceptionally important, and that is this. So I'm going to draw a random circle. well, in fact, I'm not going to draw the circle. I'm going to draw a quadrilateral. So here's a quadrilateral. Now, if you can prove, right, if you can prove that this angle over here, whatever that one is, and this angle over here, if you can prove that they are supplementary, so let's put random numbers. Let's say if you can prove this is 70, and you can prove that this is 110. So when you add those together, you get 180. So you've proved that they are supplementary. So if you can prove that they are supplementary, that tells us that there is a circle that exists over there. All right. So what I'm saying is, if you can prove opposite angles are supplementary, then you have proven that your quadrilateral ABCD is a cyclic quad. That's going to become very important because you will need to prove that certain quadrilaterals are cyclic quads, or even let's go here, or even if you have another quadrilateral and you can prove that this exterior angle is equal to this opposite interior angle. So if you can prove that they are equal to each other, then you have proven that that is a cyclic quad, that there's a circle that would exist around there. Okay, so what I'm telling you is this theorem and the converse of this theorem is going to be a very important one for you when you want to prove if something's a cyclic quad or if it is not a cyclic quad. And in fact, I think when we discussed the bow tie theorem, we said something similar, right? So here, if you can prove that this one and this one are equal, then you would know that there is a circle that exists around there. Now, necessarily, this is not exactly a cyclic quad unless I close these chords, then you have a cyclic quad, but the same thing would apply. Okay, so if you can prove that the exterior angle and the opposite interior angle are equal, you've proven your cyclic quad. If you can prove that AB, let's name this AB, if you can prove AB sub tens equal angles, you've proven your cyclic quad. Or this one over here, if you can prove that opposite angles are supplementary, you've proven a cyclic quad. That's important.